Okay, let us focus on solving systems of nonlinear equations using Newton's method. So I'll just go direct to the point on how you apply Newton's method and the formula you need to use. Okay, so Newton's method, the formula you're going to use is this here. Okay. So you have a Jacobian matrix, J of x times delta of x. I'll explain what this delta x means is equal to negative, okay, f of x. Okay, where f of x was actually the given functions. Okay, so now let me explain one by one what j of x is. The j of x, okay, is actually an n by n matrix. Okay, it's an n by n matrix. What I mean here is that if you have a system of equations with two unknowns, meaning you have two systems of equations, this will be a 2 by 2 matrix. Okay, so this matrix contains the partial derivative of the given systems of equation with respect to the unknown variables. So what I mean here is that if, for example, you are given a 2 by 2 matrix, so you are given two systems of equations with two unknowns, this Jx, Jacobian matrix, will be given by the partial derivative, okay, of G1 with respect to x1, okay. What is G1? G1 is simply the first equation here, okay. The first equation here, you differentiate that with respect to x1, okay, and then the partial derivative of G1 with respect to x2, okay. That is for the first row. For the second row, you look at other equation, the partial derivative of G2 with respect to x1, as well as the partial derivative of G2 with respect to x2. Okay. All right. So this is a Jacobian matrix. So if, for instance, you had three equations, three unknowns, here could have been G1 with respect to x1, G2 with respect to x2, the next one, sorry, G1 with respect to x2, and then G1 with respect to x3, and then the second row will be G2 with respect to x1, G2 with respect to x2, G2 with respect to x3, the third row, G3 with respect to x1, G3 with respect to x2, and then G3 with respect to x3, like that. Okay, so in our case, we all know two unknowns, so we're going to end up with what? A 2 by 2 Jacobian matrix. Okay, next, delta of x. The delta of x I've written here. This delta of x is usually an n by 1 matrix. Okay, n by 1 matrix. Okay, so n means the number of unknowns in this case, right? Okay, so if you have two unknowns, in our case, for two unknowns, we're going to have a 2 by 1 matrix. A 2 by 1 matrix looks like this. Okay, you have A here, you have a B. So this needs to be found. Okay, this is where the main focus is, to find this delta x. This needs to be found. Okay, and then finally, f of x is simply contains the two functions. So it's a set of two functions. So I'll explain what it means here. So this is a set of the two functions from the given equations. Okay, the given equations. Okay, so again, this guy is also a what? N by 1 matrix, just like delta x. Okay, so if we have two equations, this one will form a matrix of 2 by 1 in nature. All right, so now let's go back and focus on our problem given here. So first of all, we are given from the first equation, you have sine 4 by x1, x2 minus 2, x2 minus x1 equal to 0. So let's find j of x. We're going to get the partial derivative of each with respect to x. So I'll call my g1 of x. My g1 of x will be equal to sine 4 pi x1 x2 minus what do we have next? 2x2 minus x1. Okay, 2x2 minus x1. Okay, and then we have my g2 of x equal to what do we have? We have 4 pi minus 1 over 4 pi. Okay, 4 pi minus 1 over 4 pi. Okay. So just a minute. Okay, and then you have e to the power 2x. What is this? 2x1 minus e to the power 1. And then what else do we have? We have plus 4e to the power 1. Okay, plus 4e to the power 1, x2 squared. And then finally we have minus 2e1x1. Okay, so this is our g2 of x. All right, so now let's take the partial derivative of each with respect to the variable. So let's first find the partial derivative of g1. The partial derivative of g1, of course, with respect to x1. Okay, so if we differentiate that, we get so the derivative of this one here will be what? Cosine, of course, but if according to chain rule, it will be 4 pi x2. Okay, so we have 4 pi x2, 4 pi x2, and then cosine 4 pi x1, x2. Okay, and then we are differentiating this 2x2 is a constant, so I'm just going to have -1 there. Okay, so this is the partial derivative of this respect to x1, and the partial derivative of g1 with respect to x2. So this one with respect to x1. This will be equal to 4 pi x1 cosine 4 pi x1 x2. Okay, and then minus that just be what? 2. Okay, so on our 2 here. And then also we do the same thing for the other function, the partial derivative of g2 with respect to x2. Oh, start with x1. So respect to x1, if we differentiate this, we are just going to, we're going to drop this power here. So we're going to have 2 times 4 pi minus 1 over 4 pi. You have e to the power 2x1. Okay, and then minus the other part, we just have 2e. Okay, that is the partial derivative with respect to x1. Finally, the partial derivative of g2 with respect to x2. And this is just equal to 8ex2. Okay, so now put this in our Jacobian matrix. So our Jacobian matrix, therefore, will be equal to, okay, our Jacobian matrix for the first element of 4 pi x2 cosine 4 pi x1 x2 minus 1. Okay, and then here we have 4 pi x1 cosine 4 pi x1 x2 minus 2. And then here we get 2 and 2 there can cancel out, to have 4 pi minus 1 over 2 pi. Okay, and then e to the power 2 x1 minus 2e. And then here we have 8 x2. Okay, so this is our Jacobian matrix now. All right, now what do we do the next thing after? And also our f of x. Our f of x is simply contain the two matrices. So the two functions are the two equations. Okay, so our f of x will contain the two equations, which is g1 of x and g2 of x. So we have our sine 4 pi x1 x2 minus 2x2 2x2 minus x1, and then down here 4 pi minus 1 over 4 pi, and then e to the power 2 x1 minus e. Okay, obviously that's minus e plus 4 e x2 squared minus 2e x1. Okay, 2e x1. So this is our 2 by 1 matrix, as you can see here. Okay, so now we are going to make use of our initial condition. So we're going to evaluate our Jacobian matrix at this initial approximation. Okay, x naught. So we are going to make the substitution. Remember that our x naught here is simply 0, 0, 0, 0, right? So it means that x1 and x2 are zeros. So plug in the conditions here, place of x2 and place of x1, plug in 0. You notice that this whole term will be 0. The only contact we have to is -1. Okay, so I have -1 here. The next one here, if you do the same thing here, you just be left with -2, of course. You plug in 0, 0. And then down here, you'll be left with what? Okay, let's see. So if you plug in that, this will be e, the power will just be 1. So just be left with 4 pi, okay, minus 1 divided by 2 pi, okay, and then minus 2e. Okay, and that gives me about negative 3.5957. 3.5957. And then here what do we have? If you plug in 0 here, everything just be 0. Okay. In fact, I think I left out something here. There should be E. There should be an E here. Okay. Should be 8E x2. So if you plug in 0 there, just what have with 0. So this is our Jacobian matrix. We have evaluating this at the given initial condition. Okay, what of f of x of 0 as well? So again, you have to evaluate this. So in our f of x equation, we plug in the initial conditions as well. So the initial conditions are 0, 0. You notice that here plug in 0, sine 0 be 0. This will be 0, as well as that will be 0. Okay, so we just have a 0 on top. Okay, and then down here, let's see what we get. If you plug in a 0 here, what do we have? This will be e, the power 0 will just be 1. Okay, so we have 4 pi minus 1 over 4 pi, and then 1 minus E. Okay. And this gives me about negative 1.5815. All right. So this is what we get now. So the next thing is just to arrange. Okay, remember that our equation is given by Jacobian matrix times delta of x equal to negative f of x. So what is delta of x, by the way? So delta of x is simply equal to the difference between the present approximation minus previous approximation. Okay, so therefore from this we can find the present approximation by rearranging this equation. So our next approximation will be equal to delta x, and this delta x will be calculated from our Jacobian matrix here. You're going to add delta x plus the previous approximation. So in this case, the previous approximation is simply 0, 0, right? Okay, so let's go ahead and find this jx. Okay, sorry, delta x. So we have found this already. We have simplified this. Okay. So we've already found this. So in place of x, we've already done this substitution here. And then delta x again, I forgot to mention, is an n by 1 matrix as well. Okay, it's an n by 1 matrix. So for in this case, since we have two unknowns, it will be 2 by 1 matrix. And then this will be f of x at t. Okay, x naught. Okay, this, let's go ahead and just make the substitution. So this matrix is negative 1, you have negative 2, you have negative 3.59, 57. And then you have a 0. And then this delta x, I said, is actually what? A 2 by 1 matrix. So it's okay. It's known, right? So let's say it's A, comma B, right? Okay, so I'm just going to use those variables there. And then minus this matrix here was calculated as what? 0, negative 1.5815, right? Okay, so as you can see now, a system of linear equation, right? Okay, with two unknowns. So you can use whichever method you have to use to solve this. You can use substitution method, elimination method, or Gaussian elimination method, right? Okay, 0. So this one I'm going to use Gaussian elimination method. Okay. So what I'll do here, first of all, let me just send this negative way inside the matrix, right? This negative way. So if I do that, I have a 0 here, here I have positive 1.5815. Okay. Now, if I was, you can arrange this, going to start with two unknowns, A and B, need to solve for. So I'll use Gaussian elimination method. So I'll write this in terms of an augmented matrix, right? So here we have 0, and then this is negative 3.5957, and then here we have 0, here we have 1.5815. Okay. So I'll separate this with the line. So I'll do the row operation. Okay, so this one is my pivot from the first row. So I'll do the row operation by eliminating this value here below the pivot, by making that value equal to 0. So my row operation will be, okay, so R2, the value in row 2 comes row 2 minus, okay, 3.5957 times row 1. You notice that how do you do this? Just divide that value you need to eliminate, divide by the row that you're using to eliminate that value, right? So since the pivot is row 1, so we are going to use row 1 to change row 2. Okay, so of course, if the signs are the same here, you need to always have a negative here. And if the signs are different between these two numbers, you need to have a plus there, right? So you can check this. If you plug in a negative 3.57 here, you notice that you're going to have row 2 is negative 3.597957 minus the same 3.5957 times the row 1 value, which is negative 1. This will be positive. So negative and positive with the same magnitude, this definitely give you 0. So we have eliminated this value here. Okay. So now the next thing, let's change this 0 here. So our next element becomes 0. So we're going to have a 0 minus 3.5957 times row 2. Our row 2 element is simply negative 2 there. So 3.5957 times 2. So we get about 7.1914 as positive. Okay, so this is the value we're going to replace here. While the other one, the last one, okay, we have 1.5815 minus 3.5957 times row 1. Okay, so our row 1 element is simply 0. So just be the same, nothing will change about it, right? Okay. So now this will be our new matrix I want to get here. So we just try to write the new matrix. So our new matrix becomes -1, -2, 0. Here remember it's 0, and then the new element is 7.1914, and then you have 1.58157. Okay, so remember that we have A and this is B. Okay, so we are going to use backward substitution. So this is multiplied by B equal to this constant here. Okay, so 7.1914 times B equal to 1.58157. So our B is equal to 1.58157 divided by B. So we have about 0.219925. Okay, so that's our B. And then from the first equation of -1A minus 2B equal to 0. So okay, so for A, so A just equal to -2B. So if you plug in there, okay, times 0.219925. Okay, this is giving me about -0.43985. Okay, so now this is now our matrix delta X. Okay, so this is now our matrix delta X. So therefore our delta X matrix we're looking for is this here. So our A is -0.43985, and then our B is 0.219925. Okay. Now remember that we are using this, our delta X, to find the next approximation, right? And we said that the next approximation given by delta X plus the present approximation, which is X of n minus 1. Okay, the present approximation. So we just have to substitute to find the first approximation. So in this case, we're going to use this sign of notation. Okay, so X of 1. So this will be the first approximation will be equal to delta X, is that matrix that's found, -0.43985, and then is 0.219925 plus our previous approximation is 2 of 0, 0. Okay, and then this, our first approximation just comes out to be negative 0.43985, and then you have 0.219925. So this is our first approximation. So according to the question says you have to do two iterations, right? Or to do two iterations. So it means that now to do the second one, we're going to use this as our present approximation. We're not going to use this anymore. So we're going to get this and plug it in our Jacobian matrix. Okay, which matrix is that? Our Jacobian matrix is this. So those values you've seen, x1 and those representing x1, the value top, and then x2, the value down, right? So this now, we're going to plug them here to get our new Jacobian matrix, as well as plugging them here to get our new matrix, which is 2 by 1, our f of x matrix here. And then the process will continue from there. You're going to come up with a new Jacobian matrix, and also this one will be new. And then the process now will continue. You're also going to find delta x, our new delta x. Okay, so we're going to have a new delta x we're going to find here, as well as our new Jacobian matrix, and also this one will be new. Okay, and then you continue again applying the same method. If you're going to use a Gaussian elimination method or Gaussian method, you're going to use, do everything, get your new delta x. Once you get that new delta x, you come back again. You're going to find out the second iteration they want, which is the last one, of course. So it will be the previous, previously will be this one plus the delta x. So what delta x are going to get here after for solving those steps in the equation, it will depend what you have. So you're going to add the matrices. So remember how to add matrix. So the top element plus the top element, the bottom element plus the bottom element. If you have a 3 by 1 matrix, the top and the top, the mid and the middle, and the bottom and the bottom, and then you get your new approximation. So the process will continue until when you are told to stop. So in our case here, we're only asked to do 2 iterations. So it means that you're going to get the next one to be x of 2. Then you will stop. Okay, so the same procedure, only just a bit tedious, but yeah, just having patience. You get the answer. Thank you so much. And also don't forget to subscribe to my YouTube channel, invite your friends, okay? And also drop your comment in the comment section there. So that you give me the suggestions which video you'd like to see on my YouTube channel and also other contents. Thank you so much. May God bless you.